All right. Today, we're going to go ahead and look at topics 3.4 to 3.6, which is sinusoidal graphs and transformations. And this is like the start of all the trig ratios and all the stuff we're going to do this unit. And accompanied with the unit circle, it'll help you understand the unit circle as well. And I think this is one of the topics that's more useful for like calculus and stuff, especially from pre-cal, one of the more useful topics. So keep that in mind as we proceed here. Okay, so the three topics we're going to be looking at is sine and cosine graphs, sinusoidal functions, and sinusoidal transformations. Okay, first thing we're going to look at is sine and cosine graphs. So we can build these by tracing the unit circle y coordinate for sine or the x coordinate for cosine. So also remember I said what I told you guys last time we met. The number one key to succeeding in the unit three, especially, is just make it a practice of like drawing the unit circle once a day and to the point where you can get it down right away and you have it in your head as well, because that really is the key to all of this unit. So I'm going to draw it out for you guys real quick. So three lines on every side. And then we go 30, 45. Sorry, what just happened there? Computer's been acting weird today. Okay, 30, 45, 60. What is happening? Oh, I think I forgot to move your guys' like thing. Okay, that's where we're starting. Okay. Okay, so 30, 45, 60. These are degrees, by the way. And then 90, 120, 135. And it goes on, right? It increases by increments of first from not from each of these lines, it increased by 30, and then you go by increments of 15. So 120 plus 15, 135, 150, 180, and so on, right? So first, let's look at the sine. So the y coordinate for sine when it's 30 degrees. And remember, let's put this in radian. 30 degrees in radian, we have to multiply by pi divided by 180 to get this in radian format. And radian format is just like expressing the degree in terms of pi. So it is pi over 6. Now, to find sine 30, the way you can do it is a 30, 60, 90 triangle. So this is going to be my 90. This is going to be my 30. This is my 60. So if you guys remember your ratios for a 30, 60, 90 triangle, it's going to be the side opposite to the 30-degree angle is x. Side opposite to the 60-degree angle is x times root 3. And then the side opposite to the 90-degree angle, or the hypotenuse, is going to be 2x. Now, this way we can clearly see that we know that the sine of an angle, right? Sine of an angle, which is represented by theta, equals opposite over hypotenuse. So here, opposite of 30 is x, and the hypotenuse is 2x. So x over 2x equals 1/2. So therefore, sine 30 is going to be 1/2. And that's right. It is 1/2 on the unit circle as well. And the same way, we can find sine of 60, which is x root 3 divided by 2x. So because opposite over hypotenuse, right? X root 3, opposite of 60, and then the hypotenuse is 2x. Canceling the x's, we have sine 60 equals root 3 over 2. And I'm explaining out the unit circle right now, but like I said earlier, like the best way for you guys to actually like know this is you're gonna have to memorize it on your own. I can't memorize it for you guys. I can only explain it. And for 45 degrees, we're gonna look at the 45, 45, 90 triangle. So 45, 45, 90. So if you remember the ratio for this, it's going to be one side is x, one side is x. Both sides are x because it's isosceles, right? These two sides are equal. And the hypotenuse is going to be x times root 2. So here, if you look at sine of 45, it's just going to be the opposite of the angle, the opposite side to the 45-degree angle, which is going to be x, divided by the hypotenuse, which is x root 2, which this, if we cancel out the x's, equals 1 over root 2. And if we rationalize multiplying by root 2 on top and bottom, we get root 2 over 2. So the 45-degree equals root 2 over 2. And then here it follows a symmetric pattern. Oh yeah, by the way, for sine 90, just think of that any 90-degree angle, the side opposite to 90-degree angle is the hypotenuse. And the hypotenuse over the hypotenuse is just 1. So sine of 90 degrees will always equal 1. Then it gets pretty easy. You just basically need to remember those four, and then the rest of it is just like symmetrical. So like here, it's root 3 over 2, 120. It just goes like that. And here, it's root 2 over 2, the same as 45. Here, it's 1/2, the same as 30. And if we plot these points on a graph, we're going to get our sine graph. So here, let's have this point as 0. And here, we're going to have this is 0 as well. Okay, 0, and then here it's going to 1, right? So that means it goes from this point, 0, to this point of 1, which means this is at 90 degrees, which is pi over 2. Then when it returns back to 0, that means 180 degrees. So that's pi. Here it goes to -1, which it goes here, right? So, okay, I don't know why. Just gotta do this and it'll come back. Yeah. Okay. Here it's gonna be 270 degrees, 3 pi over 2. And here it looks like it goes back to our original pattern, which means it's been a full period, which means it's gonna be 360 degrees, which is 2 pi. And zooming in, we can like see the little smaller points. So like here, somewhere around there is gonna be pi over 6. And the y value for that is going to be 1/2. Here, somewhere here, it's going to be pi over 3, which is 60 degrees, comma, root 3 over 2. So that's our parent graph for sine. So here it shows us the 5 key points I was talking about earlier. When theta is another way of saying angle, the angle is 0, sine is also 0. When the theta is pi over 2, which is 90 degrees, it's going to be 1. Pi goes back to 0. So okay, here's when theta equals 0. Here, theta equals pi over 2, and sine equals 1. Here, theta equals pi, sine equals 0. 3 pi over 2, sine equals -1, and 2 pi is 0. These are going to be the 5 points you use when you actually graph the functions. The points I said earlier, you're going to need those in like for later trigonometry, like actual trigonometry where you're working with like trigonometric functions and trying to find solutions to them. You're gonna find use more precise angles like that. But when you're just trying to plot a general sine graph, these are the 5 points that you use to go off. And then here, you can do the same process on the unit circle that I showed for sine to find all the cosine coordinates. And here, cosine, when theta is 0, cosine is 1. And when theta is pi over 2, cosine is 0. Theta is pi, cosine is -1. Theta is 3 pi over 2, or 270 degrees. It's going to be 0 again. And 2 pi is going to be 1. So this is going to be our graph for cosine, right? That the x and y axis I just drew out. And if you notice, cosine is just, if this point's pi over 2, then cosine is really just the sine graph, but shifted right pi over 2 units, which from this, you get this that you guys probably learned in geometry, that sine of x equals cosine of 90 minus x. And another proof to this, obviously, is the right triangle, where it's like here, and then this is 90 minus x, right? So the sine of x is going to be this side, let's say y, over this side, which I'm just going to write hypotenuse, y over hypotenuse, and the cosine of 90 minus x is also y over hypotenuse. That's another proof to that. But basically, the cosine graph is just a sine graph shifted right pi over 2 units. So you really just need to remember this sine graph, and when you're told to plot the cosine graph, you can shift it right pi over 2, and you have the same thing. Okay, now take this graph, y equals sine theta. We looked at this graph already up there, right? Let's say on the domain from 0, comma 4 pi, right? And remember that our domain for a normal, or period is what it's called, of a normal sine graph is 2 pi. So 0, comma 4 pi is going to be this period repeating twice. It's asking at which theta values does the sine equal 1/2 from 0 to 2 pi? So where does it equal 1/2? And we went over this earlier, remember, with the key points. So think of your unit circle, because, and then think of all the points where sine of theta equals 1/2. And also for 0 to 4 pi, list all the zeros, maxima, and minima. And I'll give you guys like, oh wait, let me explain the second problem too, what it's asking. State whether each is true or false and testify. Sine of pi equals 0. Cos of pi over 2 equals 1. Sine of negative pi over 2. And remember, we went over this last class. Negative pi over 2 is the same as we have to subtract 2 pi minus pi over 2 because it's negative. That equals 3 pi over 2. So we're going from here, which is our starting point, down pi over 2 units. So then we get right there, which, no, sorry, it's wrong. It goes pi over 2 units there, and then that is 3 pi over 2. You have to check that equals 1. You have to say if cos of a negative angle equals the cos of that angle. Okay, I'll give you guys like 3 to 5 minutes on these two problems, and then I'll explain them right after. So, till then. All right, I'll explain this in 3, 2, 1. Okay, so first list all the zeros, maxima, and minima of y equals sine theta from 0 to 4 pi. Okay, first let's remember our 5 key points for sine graphs. So this is going to be x, y, okay. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the y values are going to be 0, 1, 0, -1, 0. And this would repeat again. So let's go 5 pi over 2, 3 pi, and then 7 pi over 2, and 4 pi, which these would go 1, 0, -1, 0. Okay, so looking at this, we have all our points. So let's just graph them now. 4 pi, 2 pi, pi, 3 pi. So 3 pi over 2 and pi over 2. Okay, now let's go and plot these points. Go something like, if that's 1 and this is -1, it'll go like that, 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 that. So, okay, now from this, we can clearly see the graph, right? And with this graph, we can answer all the questions they've asked. Okay, first, list all zeros, maxima, and minima of y equals sine theta on 0, 4 pi. Okay, zeros. Let's look. There's one at 0, there's one at pi, 2 pi, 3 pi, and 4 pi. So it's going to be 0, pi, 2 pi, 3 pi, 4 pi. Those are going to be our zeros, z. And then for our maxima, it's these 2 points. So that's going to be pi over 2 comma 1 and 5 pi over 2 comma 1. And for our minimum, it's going to be these 2 points. And see how once we drew out the graph, it's so easy, which this is going to be 3 pi over 2 comma -1, and then 7 pi over 2 comma -1. Okay, now which theta values does the sine equal 1/2 and 0 to 2 pi? 0 to 2 pi. Okay, remember that it equals 1/2 here when it equals 30 degrees on the unit circle, and the opposite side, it also equals here. And this is going to be 150 degrees, so it's going to be pi over 6, and 150 degrees times pi over 180 to convert it into radian is going to give us 5 pi over 6. So pi over 6 and 5 pi over 6 are 2 points. And the reason I was quickly able to know that is because I know my unit circle, right? So again, like the key to all of this is knowing your unit circle. Here, sine of pi equals 0. We have our graph right here, so we can check that's true. Check mark. Cosine of pi over 2 equals 1. And this is not true. If you know your unit circle, then pi over 2 is going to be there. And cosine, which is the x-axis, equals 0 right there. Sine of negative pi over 2, that's the same as sine of 3 pi over 2, and that's over here. And you can clearly see that that's not positive. That's going to be negative. It's actually going to equal -1, so that's also not true. And cos of negative theta equals cos of theta. This is going to be true because if you look, let's say this point right here, that equals, that's going to be, let's say, like 45 degrees. Then cos of -45 degrees equals that, which those two are the same. Here, here, like all of them, or even here is the first point, and the negative of that is going to be here. All of them are going to have the same x coordinate, which is what cosine is. So, yep, all of those are the same. So it's going to be true. So answers to that are true, false, false, true. Now, let's look at the functions. Remember what I said earlier? Cosine of theta equals sine of theta shifted left by pi over 2. No, shifted left by pi over 2. So any function with the shape of a sine or cosine wave is going to be sinusoidal. So something that repeats like this, that's going to be a sinusoidal function. So like also graphs like tan x, cotan x, which these we will get to soon enough. But for now, just worry about sine and cosine. But all these type of graphs that repeat periodically are known as sinusoidal functions. So here are key characteristics for both sine and cosine. The domain is going to be all real numbers. And this is just for the parent functions, right? No transformations involved. Domain is going to be all real numbers. Range is going to be from -1 to 1 because the amplitude is 1. The period is going to be 2 pi, which is one, the period is one full cycle of it, right? Because from 0 to 2 pi, let's say that's from 0 to 2 pi. After this, it just repeats again. And so the pattern repeats again. So the period is basically how long it takes for the pattern to start and end and then repeat. And the amplitude is 1, which is the maximum distance from the midline, which like you can do your maximum minus the midline. Midline is going to be at y equals 0. Okay. Identify characteristics. For y equals cosine of theta, identify all key features on one period. Okay. So the maximum is going to be when theta equals 0 and 2 pi, the value is going to be 1. Actually, they've just said all of them. The minimum theta, it's when theta equals pi. Let me just draw out the graph so it's all clear to see. So our cosine graph is going to look like this, where pi over 2, pi, 0, and then 3 pi over 2, and 2 pi. That's our graph. Remember, this is -1, this is -1. So there we can see that our maximum is going to be at 0 and 2 pi when it's 1. Minimum is going to be when theta equals pi and the value is -1. The zeros are going to be at pi over 2 and 3 pi over 2. The midline is going to be at 0. And the amplitude is the maximum minus the midline. And remember, the way to calculate the midline is you add the maximum minimum and then divide by 2. So 1 plus -1 is just 0. Divided by 2 is 0. So that's the midline. And then midline is the distance from this point to the maximum, any maximum. So the amplitude is going to be 1 because the midline is 0 and the maximum is at 1. So the amplitude is 1 and the period is 2 pi. Here, it's asking us to write cosine of theta as a sine function. And remember, we went over this earlier. Cosine of theta equals the sine of theta plus pi over 2. Because remember, we shifted pi over 2 units left, and then it's the same graph, right? Now, sine theta is a cosine function. Again, it would just be the inverse. So sine, the sine graph is just a cosine graph shifted right by pi over 2 units. So, okay. Compare y equals sine theta and y equals cosine theta. And I'm going to help you guys out with this. So I would like you guys to do this like on your notebooks too. So draw out both the sine and the cosine graphs. So I'm just going to write sine theta in blue, cosine theta in red. Start with cosine since I'm on red already. 1, -1. So it's going to be pi over 2 pi 3 pi over 2 and 2 pi. Those are going to be our x coordinates. And the graph will go like this. Okay, that's going to be our cosine graph. And our sine graph will look like that. Now, where does each equal 0 is one question. And then where does each reach its minimum and maximum is another question. And which starts higher at theta equals 0. Now, it says rewrite using the other function. So write sine theta minus pi over 4 as a cosine function. So remember, the key to this is going to be that sine theta equals cosine of pi sorry, theta minus pi over 2. And for this one, cosine of theta equals sine of theta plus pi over 2. So write these two functions as the opposites, the sine is cosine and cosine is sine. And I'll give you guys like 3 to 4 minutes to do this, and I'll explain it right after. All right, I'm going to explain these two questions in 3, 2, 1. Okay, let's utilize our two graphs to find the answers to the questions on problem one. Where does each equal 0 from 0 to 2 pi? Okay, first I'll do sine. So sine theta equals 0 at, and remember sine is our blue graph, so we can just look at it, equals 0 at 0, pi, and 2 pi. So 0, pi, and I wrote 2 pi there, so pi and 2 pi. And then cosine of theta equals 0 at, and cosine is our red graph. We just look at it, pi over 2 equals 0, and 3 pi over 2 equals 0. Pi over 2 and 3 pi over 2. And learning these graphs in the unit circle makes these questions much easier. Where does each reach its max and minimum? So for max, for sine equals, it reaches it at pi over 2. And for cosine, max is going to be at, if you just look at it, 0 and 2 pi, where it equals 1, 0, and 2 pi. For the minimum, min, I'm going to write sine in blue and cosine in red now. Minimum is going to be pi for, no, sorry. Yeah, minimum is going to be pi for sine. No, sorry, I meant 3 pi over 2. 3 pi over 2 for sine, just looking at the graph. And then for cosine, it's going to be at pi. Okay, now which starts higher at theta equals 0? It's pretty simple. Just look at where it equals uh, when the angle is 0, x is 0, and y equals 1 for cosine, and 0 for sine. So it's going to be cosine. Here, rewrite using the other function. So we have to write sine theta minus pi over 4 as a cosine function. If sine theta equals cosine theta minus pi over 2, we're subtracting pi over 4 to that. So let's do that to cosine 2, and then that's going to be our answer. So since we're subtracting pi over 4 to the sine, we do the same to cosine. So pi over 2, negative pi over 2 minus pi over 4 is going to be 3 pi over 4. So our answer would be theta minus 3 pi over 4. Next, here we're adding pi over 6. And for sine theta plus pi over 2 equals cos theta. If we're adding pi over 6, we have to do that to both sides. So pi over 2 plus pi over 6 equals sine of, remember pi over 2, it's just fractions. It's going to be 3 pi over 6 plus 4 pi over 6. It's 4 pi over 6, which is also 2 pi over 3. Just like that, we rewrote those two functions pretty easily. Now we go on to the final topic of the day. So transformations. Okay, so general form for transformations for sine and cosine is going to be A, which just affects the amplitude, pretty straightforward. B, which affects the period. C, which moves it left or right. And D, which equals the midline. So using these characteristics, you can pretty quickly like sketch out a sine graph. And the period is always going to be b 2 pi divided by b. So if your b value is 3, then your period is going to be much shorter. It's going to be 2 pi over 3. If your period is, let's say, I mean, if your b value is 2 pi, then your period is just going to be 1. And then it's a graph that just goes until 1. So your period depends on b. And in the same way, if your period equals this, then you can see that your b value equals 2 pi divided by period. So if you need to find the period and you have the graph, they gave you the b value, then they gave you the graph, then you can find the b value just by 2 pi divided by the period. Phase shift equals c. Positive, it's the same as like an x minus 3 cubed here, even though it's minus, it goes to the right. That's the same way the c value works in here. And then remember to factor out b in the same way where like if you have a quadratic function, you have 2x plus 4 squared plus 5. This is your vertex form. To actually get know your like compression and stuff, you'd have to factor this out. And now you have your proper shift and compression. In the same way, you have to do that with these sine graphs too. You have to factor out the b value to see the proper shift. And vertical shift equals d, and it's also the midline. Okay, here 3 sine 2 theta minus pi over 4 plus 1. Let's find all of our things. We know that the a value is going to be our amplitude because it shows how much we go up and down. So amp equals 3. Our b equals 2, right? And we know that our period equals 2 pi over b. So 2 pi over 2. So our period equals pi. We're shifting right pi over 4 units, and so our c value is going to be negative pi over 4. And our midline is going to be 1, since d equals 1. And it's shifted up 1 the whole time. Here, it's a reflection of the sine graph. So what would normally go like this is our original parent graph. It's being reflected, so the reflection transformation, I'm going to write that as the negative. That would make it start to go like that. And then finally, the 2 would make it look like this, since the amplitude increases to 2 instead of 1. Phase and vertical shift. So here we're shifting it right pi over 3 units and then adding 2. So first let's do the shift for pi over 2 units. We'll do that this. So minus pi over 3. We're going to use a blue to show it. Let's say it goes something like that. And then we have the plus 2. We're going to show in red. It would go like that. If that, and that's assuming this is the parent graph, by the way, the brown. Okay. Now, last 2 problems of the day for you guys. For each equation, state the amplitude, period, phase shift, and midline. And then write an equation for a sinusoidal function with amplitude 5, period pi, phase shift pi over 4 right, and midline y equals -2. So for this, just utilize your A, B, C, D values. Remember to factor out the B value first. Theta should be alone. And with that, you can quickly find the answer to the first question. And the second question, you can write the function pretty quickly as well. So I'll give you guys like 3 to 4 minutes to do this, and I'll explain it right after. I'll explain these questions in 3, 2, 1. Okay, so the amplitude is going to be our A value for the first question. So since A equals 4, our amplitude is going to be 4. So I'm just going to write them in order, right? So amplitude comes first, so 4. And the period is going to be, okay, we can see that our 3, which is our b value, is going to be right next to theta. Remember, we want to have it factored out. So let's factor that out to find our actual correct phase shift and b value. So 3 factor out by theta plus, and remember when we factor out 3, it's like we're dividing 3 by everything that we're factoring it out from. So pi over 2 divided by 3 equals pi over 6. So, and then that becomes that, and the -1 stays the same. So our b value is going to be 3, and remember our period equals 2 pi divided by the b value. And since the b value is going to be 3, it's 2 pi over 3. There's our period. Our phase shift is going to be going left pi over 6 units. So I'm going to write L pi over 6. And then our midline is going to be our d value, which is y equals -1. For the second one, uh, amplitude equals 1/2. Our a value is -1/2, but note that the amplitude still stays positive because amplitude can't be negative. It's just a distance from the midline to the maximums and minimums. And we factor out the 2 from here, so it becomes 2 theta minus pi over 2. So therefore, our period, which is 2 pi over b, which is 2 pi over 2, is going to be pi. Our shift is going to be right pi over 2 units. And then our midline is going to be our d value, which is 3. So y equals 3. Finally, sinusoidal function with this. So amplitude equals 5. So right away, I know our a value equals 5. So I can write that down right away. 5 sine. And then period equals pi. Remember, period, which is pi, equals 2 pi divided by b value. So our b value must equal 2 pi over pi, which means our b value is 2. Our phase shift is going to be right pi over 2. So that means right pi over 4, sorry. Theta minus pi over 4. And then midline is going to be our d value, which is -2. So 5 sine 2 times theta minus pi over 4 minus 2 is going to be our sinusoidal function. And with that, that's it for today. And make sure you guys practice your unit circle and practice out drawing the sine and cosine graphs as well. You can refer to Desmos to help you guys. And with that being said, good job today, and I'll see you guys next class.